Dear students, in this video we will deal with the answers of the sample paper that I have uploaded on my channel a few days back. So let's see the section A of that sample paper. Question number 1 is filling the blanks with the choices given in the brackets. Number first is metals are good. Metals are always good reducing agents. So metals are good reducing agents because they are electron donors. Electrovalent compounds have high melting and boiling points. Higher the pH value of the solution, the more alkaline it is. Dash is a white precipitate soluble in aqueous ammonium hydroxide, that is AgCl. Lead chloride is soluble in hot water. AgCl is soluble in aqueous ammonium hydroxide. So here the answer will be AgCl. Conversion of ethene, an unsaturated compound, to ethane. And a saturated compound is an example of how do we convert it? We convert it by the addition of hydrogen. So that process is called hydrogenation. So here the answer will be hydrogenation. Second part is state one relevant observation for each of the following. Number first is ferric chloride is exposed to atmosphere. As you all know that ferric chloride is a deliquescent substance. So you will write, since it is a deliquescent substance, it will absorb moisture from the atmosphere and turn into a yellowish solution. Electrolysis of molten lead bromide in electrolytic cell. As you all know that if you electrolyze lead bromide, you will get two products, one at cathode and one at anode. So you can write any one of the following, like at anode reddish brown bromine gas will be formed, or you can write at cathode a grayish metal will be formed, that is lead. So you can write any one observation. Lead nitrate is heated. If you remember the equation of lead nitrate, you get three products on the decomposition of lead nitrate, thermal decomposition of lead nitrate, that is yellow monoxide, lead monoxide, nitrogen dioxide and oxygen. So you can write any one observation, either a buff yellow monoxide is formed, or a buff yellow residue is left behind, or a reddish brown gas is evolved. Ferrous chloride solution is mixed with ammonium hydroxide. You will get ferrous hydroxide as precipitate. So you will write a dirty green precipitate will be formed, which is insoluble in aqueous ammonium hydroxide. Next question is gold is placed in aqua regia. Gold is a noble metal. It does not dissolve in all the acids, strong acids, but it dissolves only in the mixture of 3 parts of concentrated Cl and 1 part of concentrated nitric acid, that is aqua regia. So you will write gold will be dissolved in aqua regia. Now let's see how to write the IUPAC name of the following. Number first is CH3CO, CH2, CH3. You can easily identify the functional group, that is CO here, that is ketone, and numbering you will do from here 1, 2, 3, 4. So the root word you will write as bute, and it is at second position. The primary suffix we'll use is as an butane 2-one. So it is butane 2-one, or you can also write 2-butanone. Number second is an ether. Now I have told you for your comfort and for your easy understanding that just split it into 2, and where the number of carbon atom is less, just put the oxy word with the root word, and on the other side put the ane word with the root word. So here we will use, if you divide it, you will get here less carbon atom. So we will write root word as meth, and with that we'll put the oxy word, methoxy, and here there are 2 carbon atoms, so the root word is eth, and we'll put the suffix as ane, methoxy, ethane. Next is 3 carbon atoms. Here you have to select the longest chain, 3 here, 3 here, so we'll select this chain only. And numbering you can do from any side because the methyl group is at equal distance on either side. Now here the root word will be prop, so we'll write here prop, and here the methyl group attached at second position. There are 2 methyl groups, so we will write methyl group in front of the root word, that is 2,2-dimethyl prop, and ane simply you have to put because there is no functional group in this compound. Next is an alkene having a double bond, so numbering you will do from here this side. It to give the lowest locate number to this functional group, 1, 2, 3, 4, and for 4 you write bute, and the double bond is at first position, so you will write bute 1-ene, or you can simply write 1-butene or simply butane. Here you have a triple bond, so numbering will be done from the right hand side, and the root word here is 1, 2, 3, that is prop. Triple bond is again at first position, so we will write 1, and for triple bond we use word ine, so we will write prop 1 ine. So these are the IUPAC names of the given compounds. Next question is, draw electron dot structures of the following: ammonium ion, calcium oxide, and nitrogen. Ammonium ion, how you will draw the dot structure of ammonium ion? You will simply draw first the dot structure of ammonia. This is nitrogen having 5 valence electrons. So I have drawn these 5 valence electrons, sharing each of these 3 electrons with 1 electron each of hydrogen. And this is one lone pair. Now this lone pair will be given to the proton, that is H positive. This is totally given to this. So this is the dot structure of ammonium ion. And now simultaneously along with it you have to draw one more structure, that is called bond structure, without which you will not be able to score the marks. So N, 1H, single bond for single pair of shared electron pair, and this lone pair is totally given to the other atom or ion. So here we will put arrow, which is shown by coordinate bond, is depicted by this arrow H, and you will put the positive on the top. So this is the dot structure of ammonium ion. Next is calcium oxide. So for calcium has 2 valence electrons, so we'll put here 2 valence electrons, and oxygen has 6 valence electrons. Now if calcium gives 2 valence electrons to oxygen, both will have a stable electronic configuration, 288 and 28. And now after this you can also write this Ca2 positive, since it has lost 2 electrons and oxygen has accepted 2 electrons, so O2 negative will give you calcium oxide. Next is nitrogen. For nitrogen has 5 valence electron. If it shares 3, then it will get 8. So 3 electron you will make it on the inner side of the atoms and 2 on the outer side. Either you draw the circle or not, it doesn't matter, but I am drawing it so that I can show you. This is 8 electrons of this nitrogen atom. These are 8 electrons of this nitrogen atom. There is a slide. Just make it big so that it should be covered within this circle. It should not be on the margin. Okay, so let me draw it once again so that you are not confused. Like this. You can leave it like this also if you are unable to draw properly the circle. Okay, these are 8 electrons of this nitrogen atom, and these are 8 electrons of this nitrogen atom, and simultaneously you have to draw this bond structure as well. Since 3 electrons are shared, we put the triple bond between 2 nitrogen atoms. This is bond structure. Always draw both the structures in your board exams to secure the marks. Next question is, rewrite the following sentences by using symbol greater than or less than. Anion is always bigger in size than the parent atom, and cation is always smaller in size than its parent atom. So anion is greater than, so you will put this sign, greater than sign. IP of magnesium is always less than silicon, because across a period the IP increases, so magnesium will have less than, so you will put this sign here. In first, greater than sign, and in second, less than sign. Now arrange as the following as per instructions given in the brackets. Now number first is, first arrange all these elements as the elements are arranged in the periodic table. So how we'll arrange? We'll arrange it like this: lithium, sodium, potassium, rubidium, and cesium. These are arranged in the periodic table in a group. Now I have asked you increasing order of metallic character. In the group, metallic character increases, and here also it is written in increases, so the same order is there. This is the answer of the first rearrangement. Second is decreasing order of atomic size. So first arrange it as it has been arranged in the periodic table. So that is sodium, magnesium, silicon, sulfur, and chlorine. Across a period, atomic size always decreases, and here also it is asked decreasing order. So the same is the answer here also. If it has been increasing, you would have reversed the sequence. Next is sodium, potassium. Again you have to arrange it as it has been arranged in the periodic table in the increasing order of IP. Now let's see here. First is sodium. We'll write here silicon, sulfur and chlorine. Now I have not put potassium here because potassium is somewhere arranged below sodium, okay, in the periodic table. So just for the rough work I am writing it here. Let's see increasing order of IP. Now IP here increases and here it decreases, and you have to put in increasing order. Means you have to put the lesser one first. So I will put potassium here in front of sodium because it is having IP less than sodium. So the correct order is K, Na, Si, S and Cl. Okay, so these are the three answers for the arrangements as given in the question. Next is number 4th, fluorine, chlorine, bromine, iodine in increasing order of electron affinity. So first I will arrange according to the periodic table: fluorine, chlorine, bromine and iodine. And let's see here in increasing order of electron affinity. As you all know, the highest electron affinity is of chlorine, and you have to put in increasing order. So this will go in the last. Increasing order, okay, fluorine, bromine, iodine and chlorine. Increasing order of electron affinity. Next is again decreasing order of electronegativity. Now the highest electronegativity is of fluorine, then chlorine, then bromine and then iodine. I have to put in decreasing order, so you will arrange it in the reverse order, that is iodine, bromine, chlorine and fluorine. Name the following: a salt of zinc which is efflorescent. Here you can write hydrated salt of zinc, that is zinc sulfate 0.7 water. A metal, write the name of that zinc salt, not the formula. Hydrated zinc sulfate or zinc sulfate heptahydrate. A metal that can form base when treated with water, you can write either sodium or potassium, both of which react very violently with the water and they can form potassium hydroxide and sodium hydroxide. A yellow monoxide that dissolves in hot and concentrated alkali, that is lead monoxide. The process by which particle gain or loses electrons are termed as, collectively it is separately you may term it as oxidation and induction, but collectively it is termed as ionization. A drying agent used to dry HCl, that is concentrated H2SO4. Give reasons for the following statements. Solid ionic compound do not conduct electricity but the water solution do. Why? Because ionic compound in solid state are made up of ions which are not in the free state, but when you dissolve it in water, the ions become free and they conduct electricity. And why the ions are not free? Because of strong electrostatic force of attraction. Next is, when the stopper of a bottle full of hydrogen chloride is opened, there are fumes of air. If you open a fresh bottle of HCl, hydrochloric acid, you will see the dense fumes, visible fumes you will see in the air, because HCl gas is highly soluble in the atmospheric moisture. For electroplating with silver, we don't use silver nitrate. Why? Because silver nitrate will obviously dissociate into silver nitrate ions, but this dissociation is very fast into silver ions, which leads to uneven plating of silver on the given article. Methane is known as marsh gas. All of you know why? Because it is found mostly in marshy places, on the surface of marshy lands, wetlands or grasslands, which are mostly damp and covered with water. HCl gas is not collected over water. Why? Because it is highly soluble in water. So we don't preferably collect it over water. So this is the answers. These are the answers of section A. Section B I will discuss in the next video. Thank you.